All right, guys, so today in class, or for this lesson, I'm going to be going through the fundamental theorem of calculus part 2. It's a very basic kind of concept where what we're actually looking at is if we have a specific integral, so say if we're looking at the integral of 4t squared plus 7t, and say we're looking at it from any value, so let's just say 0 to some function, so to x squared plus 2x. So if we were dealing with this will be x squared plus 2x. Notice that something that's a little bit different is that the variables are different in this case. So we have t in our function. This is going to be in the terms of dt. But in our integral, one of the bounds is dealing with x. And what we actually do is we look at, well, what would this actually look like? Well, if we went through and integrated this, we would get 4t to the third over 3 plus 7t squared over 2. And we wouldn't need the plus c because it's a definite integral. We have those bounds, the lower limits and the upper limits. So we wouldn't have to do that. And then we would just plug in f of x squared plus 2x, and then minus f of 0, given that this was kind of our f of t. So we would just plug in those values into here, and that's kind of what we would get, and that would be the first fundamental theorem of calculus that we kind of looked at last week. What the second fundamental theorem of calculus basically says is what would we do if we took this and we derived it? So if we derive a specific integral, okay, in terms of x. Now notice that it's in terms of x, which is this value up here. Not the t values, but it's the x value up there. So if we kind of thought of doing this, because this is going to be from 0 to x squared plus 2x, you basically just work from the inside out. So we would just do the inside first, like what we did here. And we would just look at, okay, well, how would we derive this? And then we would take this and we would say, okay, well, how would we derive this? Well, what you would do is now we're just using our differentiation skills to go through and actually derive a function. Well, this is a function inside a whole function. So this would have something to do with the chain rule. Okay, this value is actually really easy because when I plug in 0, this is going to be a constant. So if I went through and I derived this, well, this would just go to 0 because the derivative of a constant is just 0. So we're just going to get minus 0 in this case. But the chain rule here says, okay, well, I want to derive this. So this is going to be uppercase f prime of x squared plus 2x. Chain rule says multiply this by the derivative of the inside, which is 2x plus 2. So this would end up giving us something like f prime of this. Well, this is just f of x squared plus 2x, because we know that f prime of x, capital F prime of x, is equal to lowercase f of x times still just 2x plus 2. So basically, I'm just plugging this function into this function up here. So you would get, as a value, you would get 4 times t squared. Well, t in this case is just x squared plus 2x, quantity squared, plus 7 times x squared plus 2x. This whole thing multiplied by x squared, this 2x plus 2. And that would be your answer. Okay, so a very basic kind of concept with the fundamental theorem of calculus part 2, so FTC part 2, basically states if we have some function or integral that we're deriving from any a value where that's a constant to any f of x value of g of t dt, what this is equal to, well, this is just equal to g of f of x times f prime of x. And this just comes from the chain rule. If we're plugging something in, then we derive it, because what we get is we get g, capital G, of f of x minus g, I don't know if this is going to fit, g of a, where this is just a constant, like I said. So that's going to, once we derive it, that's going to cancel. And then if we derive capital G, well, the derivative of capital G is just equal to lowercase g, because it's the antiderivative. So just by using the chain rule, since we have this function on the inside, we need to multiply by the derivative on the outside. Okay, so that's just kind of a good kind of thought as we go through and do it. I'll just do one real quick to kind of help you guys out if you're still kind of looking at it. So the derivative of, let's say, from 10 to 2x. So it doesn't really matter what this value is, because when you go through and derive it, it's a constant. It's going to end up just being 0 anyways. Okay, of, let's say, 4t dt. So what this is going to be, you just take this value, you take this 2x value, you plug it into the t, so you get 4 times 2x times this right here is going to be what is the derivative of that function. That's just 2. So you get 16x. All right. So if you have any questions on that, just let me know. But that kind of looks at the fundamental theorem of calculus part 2. Wednesday, we're going to go through starting to look at u substitution, which is just a different way to go through and integrate. But other than that, you guys have a good day, and I'll see you guys.